We now move to the last set of principles that we need to study in this particular course, and that is the solid principles. Right? So in the design patterns portion of this course, broadly, there are three aspects that we are supposed to look into. The first one that we did was the gang of four design patterns. The next set was the grasp patterns, which were based on the responsibility assignment principle. And the last set of principles that we would be looking at in this particular course are the solid principles, right? All the principles which are together called as solid principles, they have been proposed by a set of researchers, and they have been combined into one complete set as the solid principles. Let's understand what we mean by the solid principles. Each of the alphabet in the word solid in turn stands for another principle, right? So S stands for a principle which is called the single-responsibility principle, is the open-closed principle, L is the Liskov substitution principle, for segregation principle, and D is for dependency inversion principle. We'll be taking up each of these principles one to another, and you will be able to find out that there is a lot of overlap between either these principles and with the grasp patterns or gang of four patterns, right? But since they have been proposed by different researchers in different writings at different points of time, they have their own importance. The way they are explained, they were explained by the researchers, right? We cannot always relate every pattern in a specific language, right? These patterns, they have been proposed for overall object-oriented domain, and the languages, they try and orient themselves so that in a way they are able to provide support for implementation of these patterns, right? So this is the idea. Let's start with the first one, the S of the solid, and S stands for the single responsibility principle. This principle states a class should have only a single responsibility. And the moment we say this, we do understand this, that this is same as one of the grasp principle, which is high. The moment we say that a class has high cohesion or a class follows a high cohesion pattern, we do understand that it means that it is a single responsibility or a single task that it is supposed to do, right? This implemented a single responsibility increases the cohesion of the class. Right? Classes with low cohesion do unrelated tasks, and as well, they suffer from the problems like they're hard to comprehend, hard to reuse, hard to maintain, and quite delicate. That is, they get affected by change. And this is the reason we understood that it is very important that a class is doing only a single task, so that its cohesion remains high and it can be easily reused, can be maintained, and if it does so many unrelated tasks, it is more affected by change. Right? That is the reason we said that the player should not be responsible for writing data to the database, because if the database changes, the player changes. If the database it does not change. If I pick the player class and try to put it into another system, the player class interacts with so many classes or so many tasks is what it does, then it cannot be reused easily, right? This was the same thing that we study in the high cohesion pattern, is that class should be responsible for doing a single task only. Right? And these were the examples. I've just picked up the same examples that were there in the high cohesion pattern, is that in snakes and ladders example, who should be responsible for knowing the endpoints of the snake? Right? Or who should be responsible for knowing the color of the coin? Or who should be responsible for knowing the number obtained when a dice is rolled? Right? So these are something that are the attributes of the class themselves. Right? So it is the class themselves who should be responsible for knowing about its attributes. Right? So that would make the class highly cohesive. Right? It should be responsible for only doing the related tasks. Right? So in the first case, we say that who should be responsible for knowing the endpoints of the snake? It is the snake class itself. Right? Then next, who should be responsible for knowing the color of the coin? It's the coin class itself. Right? Finally, who should be responsible for knowing the number obtained when a dice is rolled? The answer is the dice class itself. Right? So a class should be responsible for doing only a single set of responsibilities which is supposed to do. Right? Dice class is not the right answer for this. Right? This was discussed. So, what do we mean by who should be responsible for knowing the number? So, the other word for knowing the number could be storing the number. Right? So, who should be responsible for storing the number when the dice is rolled? And actually it is the dice itself which should be responsible for storing what result has been obtained on its face when the dice is rolled. You are right when you say that if I have two coins, the cup is responsible for knowing the sum that is there in the dice. Right? But individual dice will store its own information. The cup will only be responsible for knowing the sum. So it will create two instances of dice, roll them, and take the inputs, obtain the numbers that have been obtained by rolling each of the dice, make sum out of it, and then return the final value of the cup. Right? But to be responsible for storing the information which is obtained, the number which is obtained when the dice is rolled, is the dice itself. Right? It's a single responsibility principle, which is the first one in the solid principles. Here's the next one. The next one is called the open-closed principle. Right? The open-closed principle is that software entities should be open for extension but closed for modification. Software entities should be open for extension. Let's try and understand what do we mean by open for extension. If its functionality can be enhanced by subclassing it, we say that a class is open or an entity is open for extension. So if I can subclass a particular class, then it is open for extension. When a class is a subclass, then by using the Liskov substitution rule, it can be replaced by its subclass. right? We still have to cover the Liskov substitution rule, but very easily it says that a subclass can be replaced. A subclass can be replaced by an entity of its subclass, right? This subclass behaves as its parent class, but it is an enhanced version of it. So by open for extension, we mean that a software entity can be enhanced subclassing it. Right? It is open for extension. But what do we understand for closed for modification? Let's try and understand what this principle says when it says it is closed for modification. A module will be said to be closed if it is available for use by other modules. This assumes that the module has been given a well-defined stable interface, right? So this particular module or software entity is closed for modification if it has a well-defined stable interface and is available for use by other modules, right? The other modules do not need to modify this particular software entity in order to use it. Right? So this module has been closed for modification because it is well defined, has a stable interface, and can be used as is. So we are closing it for modification, but it is open for extension, that it can be further subclassed or extended. Right? This is the whole idea behind the open-closed principle. Okay, there's a question. Let me try and address how this principle will be followed in the agile model. I think you've not got the whole idea of the open close principle. Pick up an example of the open close principle. Yes, I do have it. Okay, let's take up this example. Now, resultant of the open close principle, okay, inheritance introduces tight coupling between the classes. The open close principle is implemented using polymorphism. This enables loose coupling between the classes. Right? The open close principle says that my class or software entity should be open for extension. So I should be able to extend the functionality of that entity by subclassing it. But it should be closed for modification. That is, it has a well-defined interface so that I can use it. Right? Now, when I say it is open for extension, I can subclass it. That means I would introduce inheritance relationship between that software entity. But the drawback here is that if introduce inheritance relationship, it increases the coupling between the classes. As a result, the implementation of the open-close principle is using polymorphism, wherein we define a common interface and let the various software entities implement that common interface, right? So in that way, they are able to extend the existing software entity, and as that particular entity is open for extension, but you are not modifying it, and also not inheriting from it. As a result, not going for higher coupling. Take up an example. Let me see if I'm able to explain you in a much better manner, right? But intuitively, your open-close principle is also same as code to an right? Both of these are in phases of a coin. They both are trying to tell the same aspect in two different manners, right? So, although proposed by two different researchers with the some similar or same kind of an idea, right? They try to explain the same thing. Is that it? The close principle says that it should be open for extension, but if you use inheritance relationship to extend a particular software entity, then it increases the coupling. So instead of going for inheritance relationship, go for an implementation relationship. For the implementation of the open close principle to an interface, and in this way you will be able to even reduce the coupling. Let's take up an example. Say for example, I have a class which is called computer. Right? It has a method display. I just take up the question. Okay, a computer monitor is designed for display purposes. So the computer monitor is designed for display purposes. The computer is a product, and the computer monitor is a part or a module of the computer which is responsible for the display operation. Right? So there are two aspects. One is a computer which uses a computer monitor in order to provide the display to the user. Right? Now this computer class has a display method, right? Says display through the monitor. Right? In the main, it creates an object of the computer and invokes this dot display. Right? Now suppose there is a need to change the display of the computer from the monitor to a projector. We have this kind of an implementation. I would add another method to my computer class and say monitor, which displays through the monitor, projector, which displays through the projector. And in the main, suppose accessing it through the arguments. I say if the argument passed is monitor, then I invoke the monitor, invoke display projector. Right? Now, there's a problem in this interface, in the design. There is a need to change the display to other device. How do it? So it's not a good design. At the open close principle, classes should be open for extension but closed for modification. But in this case, we are all the time modifying the same class. If you add another display device, I will again change my class, which is an entirely wrong idea. Right? If let's do it the other way. Introduce interface. Right? This is a very typical example of code to an interface as well. An interface have an it says display module and has a method public void display. I have a monitor. Hence the display module. Hence provision for the display method, which is that display through monitor. Then projector. Hence display module provides the implementation for the display method and says display through projector. Of an implementation, you can see it's very easy to add another kind of a display, a display device. Let's go ahead. What it is now, I have my computer class, right? All I have to do is that create an object the device and invoke it. And any number of display devices can be added to this particular case without hampering computer class again and again. Coded in a manner where when we are able to quote to an interface, the system provides a concept where I'm open for functions but for modifications. Right? You're not modifying the system, deities into this addition of a new kind of a device. Let me take up a few questions if there are any. You mean we create an interface and then implement the interface in a derived class? I don't really get the question, but the idea is in case we know that there are alternatives based on types, right? The idea is you implement using an interface instead was doing earlier, right? Instead of modifying your classes again and again, have an interface, a common interface, which is then you have an interface, it becomes open for extensions. You can add any number of alternatives as you want. Okay, that's a tricky question. How will we get the questions in the exam? So, will we be given scenarios? Yes. And asked to do pseudocode for implementation? Yes, there are good chances for that. So, you'll be given scenarios to identify the kind of pattern that would be best suited to solve this particular problem, the given scenario. And you may be asked to draw diagrams or maybe asked to write pseudocode to solve that particular scenario. And earlier also I had mentioned that you have to be really careful, read the question because there are chances of a large number of more than one correct answer, right? Because a large number of patterns, like we have seen in the graphs and the gang of four, that there are a good number of patterns which do provide the same solution and try to solve related problems as well. So there will be chances that there is more than one correct answer, and of course you will be given marks for all of them in case you are able to explain your answer correctly. Okay, there's a question, will it be mentioned that you have to choose from gang of four graphs solid? Yes, there could be a chance that it is mentioned. There could be a chance that it is not mentioned. If it's not mentioned, you are open to choose. If it is mentioned, then the easier for you to choose from the small set of patterns that which one would be applicable. Solve a problem in many patterns. Marks will be given to any pattern presented in the exam. Yes. So if that's the best one, full marks. If this is not the best one, but the closest one, you will get more than in case you're able to explain it correctly. Okay, not take up this request to set a simple and direct question rather than the difficult one. Okay, we do away with the open-close principle. Let's quickly complete the rest of the three as well. So next is the Liskov substitution principle. Okay. What a Liskov substitution principle states, it states that substitutability of a class by its subclass, right? That means a superclass reference should be able to hold a subclass object. A superclass can be replaced by subclass in a superclass reference at any time, right? And Java inheritance mechanism actually follows the Liskov substitution principle, right? So I have a superclass which is shapes extended by two subclasses, rectangle and triangle. Then I can create a reference of the shapes class and assign an object of rectangle class to it, right? And this is what the Liskov substitutability principle says. So if I say shape S1 is equal to new angle, this should be superclass reference. So in this case, my shapes is superclass, my rectangle and triangle extend the shapes class. Right? So a superclass reference should be able to hold a subclass object, right? And Java inheritance mechanism in it follows this particular principle. So I hope this one is quite clear. Okay, another question which is, how do you want to justify a particular pattern by drawing the class diagram or just explaining the problem? So if a diagram is included along with the explanation, that would be really good. So simple explanation, the diagram is actually difficult for evaluator to understand, right? So it would be really good if you add a dramatic representation as well. But only diagram and explanation will also not help. Liskov looks similar to the extension part of the open close principle, right? So I did mention in the open close principle as well that this is according to the Liskov principle that a superclass reference can hold an object of the subclass. Okay. Principle again, how subclass can replace a superclass, right? This is the whole idea. If you are conversant with Java programming language, in Java this is something that is allowed, right? So if my shape is superclass and my rectangle and triangle classes extend the shape class, right? So they inherit from the shape class, they are subclasses. Then I can create like this. Means a S1, which is a reference of the type superclass, can be assigned to hold an object of the subclass, right? This is what the Liskov substitution states that should be possible. So in OOAD reference, this particular should be possible, and this is what was implemented in Java. The question is why the name is Liskov, because it is after the name of the researcher who proposed this particular principle, right? I didn't really get the question. It is inheritance. Inheritance. The inheritance is that there is a shapes class, which is a superclass, rectangle class extends the shapes class, the triangle class extends the shape class, but superclass reference can hold an object of the subclass as well, right? Okay. Let us move to the next one, which is the interface segregation principle, right? You will be able to understand to find a closeness of this principle as well with some of the other graph patterns. Now let's try and understand what the interface segregation principle has to say. It says that many client-specific interfaces are better than one purpose interface. Okay, I read it again. Client-specific interfaces are better than one general purpose interface. Right? Let's try and understand with this with an example. Suppose a module provides a general purpose interface. All the client-specific interfaces would be clubbed in one general interface. Right? So one interface methods would be there. Client 2 interface methods would be there. Right? Say, for example, I have two clients which I need to provide support to. Client 1 has a different interfaces. Client 2 has different, right? At the server side, provided support only for client 1 interface methods. Right? Then client 2 came up, wanted certain different interfaces. Same interface which was there at my server side, I included the interface methods of client 2 as well. Right? In that case, what happens? Each of the clients would not be required to provide implementation for the other methods as well. There in the common server interface, but not supported by that particular client. Of course, in their implementation of the methods which they do not support, they would throw an exception as to unsupported option. Try and explain again. Client 1 and 2 has its own methods through which it interacts with the common interface. Right? The methods are and CM1 and CM2. Right? So the common interface, which is my server side, has methods. Okay, let me just add here. It has the methods C1 M1 and third C1 M2. Right. Now I provide for client 2 method C2 M1 and third C2. Now what happens? My client 1 will now be even required to provide implementation for C2 M1 and C2 M2, implementing a common interface. And in that case, it would simply say, that throw an exception as to unsupported option. Now, there's a problem. Now, suppose I want to add another client 3. First, I will add the client 3 methods as common interface, and then each of these 3 need to again provide implementation for those additional common methods which added into the common interface. Now, the interface segregation principle says that instead of having one general purpose interface, Let's have many client-specific interfaces. How to do this? Let us have one common interface with one common method. For example, main interface. Here is the whole crux. Each client-specific interface, right? We have more interfaces, which are client-specific interfaces, which extend common interface and provide implementation for main interface method and additional methods specific to the client. I have a common interface which has the main method, say for example main interface, and I have multiple specific interfaces which extend the interface. So each client will no longer be required to provide implementation of for the additional methods that are being added by the other clients, right? So if I have a client 1, I will have an interface which is called interface client 1. Common interface client 1 will be for the main interface and the additional methods. Again, interface client 2 will extend the common interface and adds its own additional methods which are required for client 2. Having large number of interfaces for each client prints the for providing implementation for the methods they do not support, and it then becomes easier to add as many number of clients as required. The client will first come and extend the common interface on client specific interface and then do the interaction. Draw a diagram for the explanation. I just try and draw it. Be the behavior in the scenario where client 1 and client 2 needs M1, where client 3 does not need it. Should be handled by the individual client. So this is the problem that we are trying to solve. If client 1 and client 2 needs M1 and client 3 does not need it, right? But since they are implementing the common interface, client 3 would be required to provide an implementation for it, maybe by saying that it's an unsupported operation, right? I just try and draw and trying to represent this. My common interface, just say one method. Common interface ends the a common interface might be having a method, say main method. So this particular implementation for main method interface. My client common interface is an interface which extends an interface, right? You can go through this idea wherein you can even extend an interface. Right? We are not implementing an interface. A class would implement an interface, but here my interface extends an interface. Right? A common interface which you are trying to extend using a client-specific interface. Okay, I'll repeat again. The common interface is a combined interface which every client is invoking, right? See, there is a super interface and sub interface kind of a relationship. There is an inheritance relationship which is existing between the common interface and the client common interface. My client common interface is an interface which extends the common interface. Right? So I did an implementation for the main method and it will add its own methods. Right? Even M1, M. All my clients will interact with this common interface and invoke the main method itself. Yes, take up a question. To handle generic operations as common interface, so this is my generic method, the main method, which will be the common interface to all the clients. This main method will in turn help me to interface with the client specific. My client 1 will create a reference of common interface and will instantiate client common interface references. Chat which is coming up, it says it's enough, so much is enough to be covered during one session. I agree with you, and we have limited sessions. Okay, so we try and resolve this to self, because there's one more aspect that we need, one more final principle that we need to cover and close today. I hope this interface segregation principle is clear, right? So you are trying to, instead of having a general common principles adhering to n number of clients, you try and provide client-specific interfaces. Okay, let me move to the last one for today's session, which is the dependency inversion principle. Okay, just two more slides. The dependency inversion principle says that depend on abstractions, do not depend upon conditions, right? Or in other words, it says that high-level modules should not depend on low-level modules, should depend on abstraction. Right? You will see this, as you understand, you will understand that this dependency inversion principle is quite close to something that we have been saying so far, is that the high-level modules will depend on low-level modules for carrying out the tasks assigned. They are highly coupled. Reduce the coupling between the high-level modules and the low-level modules. Right? And how do we do that? Introduce a level of interaction. Introduce a layer of abstraction between them in order to lower the coupling and dependency. Right? This is what something that this principle tries to address is that you introduce indirection between the low-level modules and the high-level modules so that they are independent of each other, right? They reduce the coupling between the two levels by introducing a layer of abstraction. And how do we introduce a layer of abstraction? Introduce an interface. Common interaction, a common abstraction between the two so that they are decoupled. Right? You will be able to modify the lower layers or extend without disturbing or changing the higher level layers. So each of the layers, so instead of putting it vertically, saying higher and lower level layers, you can even put it horizontally, that a particular set of objects, a particular module is highly coupled with another module. Reduce the coupling by introducing a level of indirection by introducing a level of abstraction, right? So the lower level layers, they are also implementing an interface which the higher level layers are using, right? So your interaction of the lower level layers is through that interface. You can add new lower level modules, the modules which implement the same interface, right? And the dependency of the higher level modules on the lower level modules get reduced. There is decoupling between the two layers, right? Does violate the layering principle? You're not violating the layering principle. You are reducing the coupling between the layering principle. So in case you want to remove a module of the lower level layer and plug in it with a different module, right? You have a level of abstraction between the higher level and the lower level, which in our case in the OOAD design is a interface that you introduce between the two, right? We know that the lower level layers implement an interface and all the higher level layers invoke that particular interface. This will increase the complexity. The complexity has to be increased in order to lower the coupling between the two layers, right? Because the design should be such that it should be able to accept changes, right? So a good design has to be one which is able to accept modifications or changes, and this is the reason why we are going with the dependency inversion principle, because if there is a requirement in a change of module at the lower level, then because the coupling would be so high, it would be difficult to replace the lower level layer, right? So let me explain it with an example. So if a class C1 which is higher level and there is a class C2 which is at a lower level, C1 extensively uses the objects of C2. So that means they are highly coupled. But I introduce an interface between them. C1 does not know existence of C2. It only interacts with C2 through the interface I1, right? So it always invokes I1 dot do task, I1 dot do my task, right? I1 has been assigned an object of C2 at runtime. Right now, if I want to replace C2 with C3, my C1 is not bothered. C1 continuously keeps on invoking I1 dot do my task. At the runtime, I1 is, instead of referring to C2, now starts referring to C3. Right? And I'm able to replace from C2 to C3. I have reduced the coupling between the two layers. I can still go ahead and replace C3 with any other class type. The C1 is not bothered, long as my lower level class continues to provide implementation for the interface layer that is between them and the lower levels. This have there's a question, but this will have a single point of failure, right? So when we are at the point of designing, we are designing with the aspect of accommodating change, right? And I really do not understand how will this lead to a single point of failure. That's a question. You cannot relate that with having a common abstract layer. Okay. The two things are totally different. Okay, there's a question, why the name dependency inversion principle? So you are moving dependency from the lower level modules to a common abstract layer. Why it says dependency inversion principle. There's another question which was asking that, is this the last lecture for the course? Effectively, we've covered the entire course by today. A question for some of the solutions of the regular examination. I would try and upload the solution if it is available. Here it is. I will upload the same. Will the results of makeup exam be out Monday? I would upload a detailed syllabus for the comprehensive examination. We'll do that definitely. No class tomorrow. Yes, please, there is no class tomorrow. We might have a tutorial session or a class on 17th November. That is the next Saturday, where we have a scheduled class. Please look out for the announcement. Might have a tutorial session or a lecture on 17th. Comprehensive examination, more questions will be after mid-sem course. There will be more questions after the mid-semester course. You have questions from mid-semester topics as well, right? So there would be something around 15 or so. If the paper is for 50 marks, no, it's for 45 marks. The comprehensive paper is for 45 marks. So roughly 15 to 20 marks from the pre-mid-semester course syllabus, and rest from the post-mid-semester. Just repeat, our comprehensive paper is for 45 marks. It is open book, roughly 15 to 20 marks from the pre-semester portion and rest from the post-mid-semester. If there's a question, is it enough we cover the principles, patterns covered during the lecture sessions? Yes, it is enough. You can go through the patterns and principles which are covered in the lecture session, because I have covered all that is mentioned in the course handout. I would put up a request for uploading the previous semester's comprehensive examinations. I would try and do that. Okay. Okay, this question says that there are two more slides. What are the rest of the slides currently? No, they are just the snakes and ladders case study slides, which I had put in order to understand, in case we require the case study, right? So I think that's it for today's session. Let me just close my screen and I can just take up a few more chat if there are questions. Updates will be uploaded by Monday. Upload the these for uploading the phase 2 submissions as well. The date for submission for phase 2 is 8th November. There will be no action to that. It's a hard deadline. We cannot go beyond that. I think that's it for today. In case you have any queries, please do write mails to me. I will try and respond to your mails.